So we'll be making Pong today with Pygame and Pymunk, where the two players are going to be controlled with the keyboard. First thing we need to do is import Pygame, and then we'll import Pymunk. So Pygame is going to be our display module, while this will be our physics engine, Pymunk. And so whenever we use Pygame, the first thing you want to do is just initialize it right away. Now we'll create a variable that holds our display. So that's pygame.display.set mode. And it's going to take a tuple as an argument that gives you the X and Y number of pixels for the display. Okay, so let's run this. So we have this window now, and of course it shows nothing, and it has no idea what to do, which is why it's not responding, because we haven't told it to do anything. So first thing we want it to do is going to be the refresh at a certain rate, which is going to be our frames per second. So to do that, we need to create another variable called clock, which is going to be a pygame.time.clock object. And then let's create a variable which is going to be our frames per second. We need a while loop to occur every time that the frame refreshes. So we'll create an infinite while loop. And to do that, we can use the tick method of the clock instance and pass through our frames per second. And in this while loop, we want to update the screen, which we can do with pygame.display.update. And if we can ever get out of this while loop, we want to also quit the Pygame screen. So let's go ahead and run this. And now we have an empty window again, and you can't really see this, but it is refreshing at whatever frame per second we gave it. I think we gave it 50. But right now it still doesn't really know what to do with clicks and things like that. So we still have not responding. So now we have to tell it what to do when we click. So I think the first thing that we should do is be able to get rid of this screen. So we can click this X button up here. So to generate that, we now need to go through what are called events. So events are mouse button clicks, keyboard clicks, things like that. And every time we run through the game loop, we're going to want to run through the event loop. So for an event in pygame.event.get is how we're going to run through the current events. So to determine if the X button was clicked, we have an event type called pygame.quit. What we want to do is we want to get out of this while loop. So the question becomes, how can we get out of the while loop when we're still in the for loop? Break will not work because that'll just break this event loop, but it will still continue with the game, and we want to exit out the whole game and the whole display. So in Python, the cleanest way that I know how to do it is to set all of this inside a function. So I'll call this function game, and then we return out of the function. So by doing this, when we hit this return, we actually end this whole function, which is ending the while loop. So of course we're gonna have to run this game function to ever get a chance to do it. So once we get out of this game function, then we'll quit the display and we should be good. And let's just fix this. So let's try running this. So now we have our window. Still doesn't really know what to do with the clicks, except we can X out of it. So now we need to add a Pymunk space, which I'll do up here. Pymunk space is a simulation space for the physics of the Pymunk physics engine. So what we can do is we can step through the simulation space at the same time as we run through the game loop. Space.step, and this requires a time parameter. So we use 1 over frames per second, so the number of seconds per each frame. So the question is, does this have to correlate with our display? Not necessarily. The lower this number is, the more accurate our simulation, but also the slower this program runs. A good basis is just to correlate it with our frames per second. Okay, now we have to start actually drawing objects onto our screen. But before we do that, let's take a second to look at the geometry of what we're trying to draw. So imagine this black outline is the screen, the display that we have. Now Pygame does something interesting with the coordinates. The top left is where you have your 0, 0 point. So the Y coordinate is 0 at the top and increases as you go down. This is a little counterintuitive, so something to keep an eye out for. We want to create walls for our game. So we want to define variables that refer to this point in X and this point in X, which I'll call left and right. And we also want to do the same for the top and the bottom of Y. Additionally, I want to define 2 more variables that refer to the middle points in both X and Y as such. So this middle X will be 500 in this case, and this middle Y would be 300. And as long as all our margins are symmetric, middle X and middle Y will also refer to the middle of the playing field itself. Okay, so let's make those variables now. So we have left, and I'll say that's about 50. right, we'll make that 950 just to keep the margins symmetric. We have top. So top, we'll make that 25, and then bottom, again, to keep it symmetric, 575. We also need a middle X, so let's make that 500, and then middle Y will be 300. Now it's time to start making a class for each of the objects that we're gonna have in our game. So we'll start with the ball, say class ball, and then within our init method, we're going to do everything we need to add this object to the Pymunk space that we've created. So one thing we need to do is create a body. So the body is a point-like physics object in the Pymunk simulation. Pymunk.body. Now let's set its position and velocity. And we'll make it start in the middle. And then for velocity, I'll make these numbers up. And the scale of these numbers for velocity depends on the step size that we had used in the space. So they're a little bit arbitrary. I would suggest just mess with it and you can figure out what works for your simulation and what looks the best on screen. And we also have to create a shape attribute. And the shape is going to be the collision shape for the bodies. So the body is the point-like object. But for the body to interact with other objects in the simulation, we need to know a shape that it should assume for the collision dynamics. For the ball, it should be a circle. So the circle requires two arguments. First, the body that it's attached to, as well as a radius. So we'll say 8. Again, you can mess with these numbers and see what looks better in your simulation. Now we can set the shape's density value to, I'm going to set it to 1, but you'll see later it doesn't actually matter. And we can set the shape's elasticity value, and this will matter, and we should set it to 1 so we can have elastic collisions between the players, the walls, and the ball. Now we have to add the body and the shape to the Pymunk space that we had before. So space.add, self.body, and self.shape. So there's one last thing I want to do in the init method for the ball object, which is create a collision type for the shape attribute. And I'll talk a little bit more about what this is when we create the collision handling system. Now let's create a method within ball that will draw the object onto the Pygame screen. Now Pygame gives us some basic functions to draw shapes onto the Pygame screen, and I never remember how to use any of those functions, so I'm just going to look at the documentation here. So you can find this documentation if you Google it, or you can look in the description of this video. If you go ahead up here and click draw, and we're going to look for circle. So Pygame draw circle, it wants the surface, which is our display, a color, a center, and a radius. Okay, so let's put that in. Pygame.draw.circle. We have a display, and I'll make this white. And we have the center, which will be self.body.position, and then a radius. Now, let's make an instance of this ball class in the game function. I'll call it ball. And in our game loop, we can use the ball.draw method to draw the ball every single time the screen refreshes. Ball.draw. And I'm going to tell you right now, this is going to throw an error. Integer argument expected got float. So what's happening here is the self.body.position is going to end up being two numbers, which are both floating point numbers as per the Pymunk simulation. Unfortunately, Pygame does not support floating point numbers or decimal numbers. So we need to turn these into integers. So let's go ahead and do that. We'll say x, y equals self.body.position. And then instead of passing self.body.position, we can just pass a tuple that's the integer of them. So that's one way to do it. So if we run this, there's going to be another problem with this. The ball draws over the image of the previous refresh of the screen. So we need to refill the background as black every single time the screen refreshes. So let's go ahead and do that. So prior to drawing the ball, we need to say display.fill. And like I said, I want the background to be black. So say 0, 0, 0. And now we have a ball. Okay, so let's make another class for the wall. And this is going to be the same idea. However, in the init, I'm going to bring in two variables. I'll say P1 and P2 for point 1 and point 2. And this is going to be because there's 4 different walls. and each one is going to have a different point 1 and point 2, which is going to be the endpoints of the segment. So again, we'll create a self.body. However, there's going to be a slight difference here. We're going to have to set the body type to equal pymunk.body.static. So what this does is when the ball bounces off the wall, we don't want any of the momentum of the ball to be transferred to the wall, allowing the wall to move. We want the wall to stay static. Okay, so now let's create a self.shape. And let's call this pymunk.segment. Segment takes 4 different arguments, the body, A and B, which are offsets to the position where you want the endpoints to be. Since we didn't define a position, our position is 0, 0. So our P1 and P2 happen to be those offsets. P1, P2, and then radius is going to be the thickness of the wall. Let's make it a little more than the radius of the ball, 10. And then let's set the elasticity. Again, we don't need to set the density because this is a static object. We want to set it to 1. Now, one more thing I forgot to do is we want to add a collision number here, just like we did in ball. And again, I'll explain this when we go to the collision handling part of this. And I'm going to have a default value of none and say if collision number, so if it's not none, so if it's provided, then self.shape.collision type is equal to that collision number. Draw method. And again, I always forget the function for drawing lines in Pygame. So we're going to go back to the documentation. We're going to go to draw. We're going to go to line. Surface, color, start, and width. All right, so surface, color, start, and width. Pygame.draw.line. Display. Color, we'll make it white. Surface, color, start, and width. Self.shape.a would give us this first offset, or P1. Self.shape.b would give us P2. And then width, again, refers to the thickness, so I'm going to say 10. Now in a game function, we'll create 4 instances of the walls for all 4 sides. So I'll say wall left equal wall. Now let's give our P1s and P2s here, remembering that P1 and P2 are the positions of the endpoints in X, Y. So for P1, on the top left, so we have left top, X, Y, and then left bottom. And I'm sending them in as lists, but you can send them in as tuples. And I'm going to give the left side a collision number of 2. Now I'm going to do a little bit of copy and paste to make this easier for the right side. And say anywhere it says left, I'll change it to right, and I'll keep the collision number as 2. Now for the top and bottom, I'll say wall top equal wall. So creating an instance of our wall class with the top lefts, left, top, and then top right. So right, top, and I'm not going to give this a collision type. And with the magic of copy and paste, we can make our wall bottom. And we change everywhere we see top to bottom. So this is why it came in handy to have these defined earlier. Now, of course, this isn't going to show up on the screen unless we draw them. So I'll say wall left.draw, wall right.draw, wall top.draw, and then wall bottom.draw. And I do want to fix one mistake before I run this. In the wall class, the init method, the word static needs to be all capital. Sorry about that. All right, so now we have our walls. And as you can see, the Pymunk system is working, right? Because the ball is bouncing off the walls without us having to write any of the physics that's required for this. And that's the advantage of using a physics engine such as Pymunk. So we'll create one more class called players. And then we define the init. And then what changes between the 2 players? It's actually just the X location. We're going to start at the same Y location between the 2 players. So we'll just bring in X as the argument. Self.body. And this will be interesting, right? Because we can't use a static body because, as we did earlier, for the wall class, the static body cannot move. But we want our players to move. However, we don't want them to participate like the ball in the physics simulation because we don't want the player to be moved. So there's a third body type called kinematic. that can solve these issues. And that's what we're going to use. We should set the position, and we're going to set the position to be in the middle of the player. So we'll start it at the given x, and then middle y. Now let's set the shape. Self.shape equals Pymunk.segment again. Again, self.body. However, these two are the offsets from the position where the endpoints are. So let's look at this again in animation. This is the animation we had earlier with the ball and the players now. So we have our position defined right here in the middle of the player. Our offsets are going to be slightly up and slightly down, so slightly positive y and slightly negative y with no change in x. So let's go ahead and write that. So 0, I'll say negative, let's make our player size 30. And then the next offset will be 0, positive 30. And if you flip those orders, it really doesn't matter at all. Now, how thick do we want this player? So we'll keep the player at 10. And again, I don't really know if these parameters are going to be good for the game, but we can mess with those at the end. We should set the elasticity to be 1 again. Now we want to add the player to the space. So we have to add both the body and the shape. And let's create our draw method. So there's going to be a slight complication to the way we do our draw method in the player class versus in the wall class. The reason being is in the player class, our position always stays 0 and our offsets are going to be the same as our position in Pygame. However, in the player class, our position starts in something that's not 0. So we need to convert our endpoints from what are called local coordinates, which are relative to the position, to what are called world coordinates, which are not relative to the position. So relative to the overall simulation. So luckily, Pymunk gives us a function to do that. So I'll say P1 equals self.shape.a and P2 equals self.shape.b. So this A and B again refers to this offset, but the offset is in local coordinates, and we want these positions to be in world coordinates to be able to draw them on the Pygame display. So the function for that is self.body.local to world. Okay, now we can draw the line, and I'm definitely going to cheat here. I'm taking this from the wall class. But instead of self.shape.a, I'll toss in P1 and P2. Again, the order doesn't really matter. Now let's create 2 player instances within our game function. Player 1. And I'll make player 1 left plus a bit of a gap. I'll say 15 pixels. And then player 2 is same thing, right, but 15 fewer pixels to give that gap towards the left. To reiterate, the x position of player 1, which is this player right here, will be left plus, I'm calling this gap about 15 pixels. And the position for player 2 will be right minus, in the x direction, about 15 pixels. Now for the player to show up on the screen, we must draw the player. So player 1.draw, player 2.draw. So there's one more thing we have to fix before we can run this, and that's going to be back in the player class in the init method. It's not self.position, but it's self.body.position. Okay, so let's run this. So we have our players that show up on the screen. They don't move from keyboard input, but if the ball ever hits the player, you can see that the players are active in the physics simulation. So now let's get the players to move. So within the player class, we're going to create a move method, define move. And one of the arguments is going to be a Boolean that determines whether we're moving up or down. So I'm going to say up, and then we'll give it a default value of true. So we'll say if we want to move up, we can set the body's velocity upward. So that's going to be a 0 for x directional velocity, and then a negative for y directional velocity, remembering that the y direction is more negative as we go higher. And then the opposite for down. So else, which is down, body.velocity, we'll say 0 for x, and then positive 600 for y. And again, this velocity absolute value depends on the physics step size in the physics engine. So you can mess with that value and see what works best for your simulation. So now we have to call this method based on the keys that we press. There's 2 ways to do this. One is within the event loop, but that only works if we had one key at a time that we're going to be pressing. But since we have two different players, we may have two keys being pressed simultaneously. The way to handle that is within the game loop itself. There's a Pygame function that returns a Boolean list representing if all of the keys on the keyboard are pressed or not. And we'll save that list in a variable called keys. And the function is pygame.key.get pressed. The index for the up button is keys of 273. Honestly, I never really found in the documentation which index refers to which key. I kind of just played with it until I found the right numbers, but I'm sure it's in the documentation somewhere. So if this value is true, that means the up button is pressed, and we want to move player 2 upward. We can use our move method, player2.move, and we don't need to give it a parameter because we want to go up, and the default value is true for up. Then we can say elif keys of 274, which is to down, player2.move, and then we want to say false to move downwards. Lastly, if neither of them are pressed, we want to stop the player, so we'll say player2.stop, and we haven't written this method, so let's go up and write this method in the player class. So we'll say define stop, and all we need to do is set the self.body.velocity to 0, 0. So let's run this. Player 2 can now be controlled with the up and down arrows. So back in our game loop, we need to do the same thing for player 1. And we'll use the W for up and the S button for down. So I'll say if keys 119, which is the W, and I'll write a comment here to remember that. Player 1.move with no argument. Elif keys 115, and this is going to be the S. Player 1.move and then false to go down. And of course, lastly, else. So if nothing is pressed, we need player 1.stop. So let's run this. Player 1 is moving up and down, and player 2 is now moving up and down. So the last thing we need to do is have the ball reset every time there's a goal. We're going to go up to the ball class, and we're going to write a method called reset. Define reset self, and we're going to need 3 arguments here. And these 3 arguments come from how Pymunk handles the collision system behind the scenes. So it doesn't really matter to you exactly what's going on with these arguments, but they need to be in there, otherwise Pymunk will throw an error. So the recommended names for these is space, arbiter, and data. However, it doesn't really matter what you call these. And for the sake of logic, let's spell space correctly. So within this method, we want to restart the ball's position and velocity where we had started it in the init method. So I'm just going to go ahead and copy and paste the position and velocity from the init method. Now let's actually generate the collision handler. Within the game function, we're going to make an instance of a collision handler, and we'll save that instance in a variable called scored. The collision handler object comes from space.add collision handler, and the 2 arguments it takes are going to be the collision identifiers that we use when we set our collision types for ball and for the wall, which we've set as 1 and 2. So we'll say 1 and 2. Now you can see why we set those collision types. So what this collision handler will do is allow us to tell the Pymunk simulation what to do when 2 objects collide with these 2 identifiers. So what we want to do is run the reset method. To do that, we set the begin attribute of the scored object, scored.begin, as the method that we want to run, ball.reset. Now, one thing we have to do with the reset method is we're going to have to return a Boolean. This Boolean represents if we want the Pymunk simulation to actually run the collision analysis for this collision. And at the end of the day, it doesn't actually matter in our case since we're resetting the position of the ball, but we could just set it to false. So let's go ahead and run this. And now every time the ball scores, it's going to reset back to its original position. This game is completely functional now. Now, as you play around, you can notice there are problems with this. For instance, the players can leave the screen. And we'll talk about how we can fix these problems in the next video, as well as add more functionality to the game.